Let's talk a little bit more about how the positions of synchronized networked game objects actually are updated over the network. Say this is my client here. We're playing a very, very simple game where there is a box and we can move it around the screen. On my client, the box is currently here at this position. And on your client, you have the same visual as me. The box is there. Now, remember that video games in general are just updating what we're seeing on the screen really, really quickly, right? Nothing actually moves smoothly in video games. Nothing actually moves smoothly in any of the simulations that we're developing. And we're just moving them by very, very, very small increments, right? The issue with updating an object over a network like this is that we can't realistically send every single position that this object moves to over the network. We would essentially just be flooding our network or flooding the internet with so much data, right? If this game is updating at, has a refresh rate or has a frame rate of 144 hertz or something, we would be needing to send 144 messages over the internet for this client to receive and process to keep it on pace with this one. So we don't do that. What we actually do instead is we send position updates at smaller intervals. Typically, the default in the networking library that I frequently use, the default is somewhere around 10 times a second. So what we actually get is, on this client, if I move my object to the right, then on this client, what it actually receives are small position updates like this. Notice how they are discrete, individual positions that are going over the network. As I move smoothly, it's essentially saying, once there are 10 times a second, let's send an update over the network to all the other clients to let them know where I am. So, now we are posed with this situation. We have a client here who has an object, and we just got a new position, this one, over the network sent to us. We need to somehow take this object and move it to this position to make sure that it stays in sync with how the original client is moving their object. One thing we could do is we could say, well, we just got an updated position, let's just set it here. Let's just take this object and move it to this position, right? But the downside is that our game is going to look very jittery. It's going to look like it's only moving this object at 10 times a second. It's going to kind of look like we're running at 10 frames per second, which is pretty bad. So instead, what we want to do here is we want to use this idea of interpolation. We want to use the idea of interpolation to smoothly move this object from its current position to the new position that we just received over the network. The second thing that may happen, these positions are going to be sent 10 times a second, or whatever the rate is of your network simulation. And there may be times where there's latency there, where there's fluctuation in how often these messages are sent and how often they're received. One situation that we may run into, which actually happens pretty frequently, is if we move this object to this new position, what happens if we haven't received the next position update yet? What happens if you're moving your object smoothly across the screen and I get the first update, but I haven't received the second one yet? By the time my object gets to the first one, now what am I supposed to do? Well, this is where something called extrapolation. Extrapolation comes into play. And that essentially means our client is just going to guess at where you're moving based on previous information that we know. This combination of interpolation, meaning moving to new positions that we've received, and extrapolating, meaning moving beyond the positions that we've received and essentially guessing where you're going, is incredibly common in video games. It's used in almost every single online multiplayer game. When you're playing an online game and you see one of your friends disconnect, and then their character just keeps running straight, and eventually they're just running into a wall, that is extrapolation. Your client is moving them forward until they hit a wall, and it's not getting any corrected information from them. You are literally looking at your client extrapolating forward the position of other players because of the high network latency you're experiencing. When you are playing side by side, and if you had two monitors right next to each other, and one person moved forward, and then you saw on the other screen this sort of smooth movement to catch up to it, right? But this latency behind it move, and then the other one sort of moves smoothly to it. What you're seeing is the interpolation, the moving from where I currently am to the position I've just received. So this combination of interpolation and extrapolation, knowing how to switch between them, and some of the techniques that we use on how to make interpolation and extrapolation work really well for specific simulations and specific games that we're developing is really important for the overall feeling and the overall gameplay that you're providing.